Hi guys, hope all of us are doing great. In this specific discussion, we're going to look at the third method of finding the limits. So this is going to be in collaboration with the first one of substitution and factorizing or factoring method that we had done in our first two videos. So the concept of a conjugate is going to be, of course, an aspect of binomial expressions that are going to be expressed in terms of the same expressions but with the opposite signs. And in this case, we can be able to give a range of expressions which are going to be expressed as conjugates. And basically, these are going to be useful in methods which are going to be involving what we refer to as radicals. So in that case, if I put a number like that, then that's going to be a radical expressed as such. So therefore, if I have the root of 2 minus 3, this is going to be regarded to as an expression. And if I'm able to write another expression or a similar expression with an opposite sign, which is the root of 2 plus 3, then therefore this is going to be, so if I refer to this one as A and B, so A is going to be a conjugate of B, or B is going to be a conjugate of A in that specific respect. So we're going to use that strategy in trying to find the conjugates of specific numbers, which are going to assist us, of course, in trying to find the respective limit of a number. So the expression I've given on the board, or rather the function, is consisting of one such expressions, and we're going to use it, of course, in trying to show how this concept of conjugates can be able to be used in trying to express the value of this limit. So in our first state where I was talking about the factoring method, I used the concept of substitution. And of course, we found out that substitution is not going to be handy in trying to assist us find limits of specific functions. So for today as well, we can be able to use this aspect of a limit for this function and try to see what value it's going to give us. So in any case, if we try to use the substitution method for this, we're going to see that this is going to be substituted. The value for x is going to be substituted by 5, whereby we're going to have it given as the root of 5 plus 11, or the root of 5 plus 11, 5 plus 11, the root of 5 plus 11 minus 4 is equivalent, or rather over 5 minus 5 is given as such. And this is going to give us the values of 0 over 0, which of course are not going to give us a clue on how this limit can be expressed. So therefore, we're going to multiply the numerator and the denominator by a conjugate of the radical expression of the root of x plus 11 minus 4, which I've given on the board, so that we can be able to find the limit of this particular function. So therefore, we're going to proceed from this by having this one being given as the root of 11, or the root of x plus 11 minus 4 all over x minus 5. So we multiply by the conjugate of this specific value, so it's going to be the root of this specific number of x plus 11 plus 4. So we have changed the sign of this specific part and just maintained the radical as it is. So this is going to be also multiplied by the root of x plus 11 minus plus 4 as such. So we maintain this aspect of the conjugate values so that we can be able to evaluate that specific function. So therefore, this is going to give us the limit of as x tends to 5 of this specific function given as. So whenever we multiply the respective conjugate values of that specific limit, we're going to get that value. So we're going to get x plus 11 without that radical sign that we have shown in that specific expression. So it's going to be x minus 11, giving our first part of this expression. And then this is going to be minus 16 for those two respective values of a negative 4 and 4. And then that is going to be given as over. So this for the two denominators, and therefore they are just going to maintain that one. Since we are going to multiply this one in the those specific signs for the radical, and of course this first part of the expression that I've given as such. So in this case, of course, we're going to evaluate that one, and the value for the upper, which is going to form part of the numerator, of course, is going to reduce to x minus 5, and then the lower part still is going to be a value that is a product of x minus 5 and then this specific radical for x plus 11 plus 4 given as such. So if you try to look at this, then therefore we're going to have common factors for the x minus 5, and those ones are going to cancel out and give us a value that's going to be, perhaps I'm going to use the upper part to continue this evaluation. So in this specific case, from this step, we're going to have a value that's going to be 1 over the root of 5 plus 11, and then plus 4 given as such. So in our last case, I've done a substitution for this value of x, whereby I'm going to get the value of the root of these numbers, which are going to be, of course, the root of 5 plus 11 is the root of 16. So the root of 16 is going to be equivalent to 4. So 4 plus 4 is going to be equivalent to 1 over 8. And therefore, that is going to provide for me the limit of this particular function that I've done for this. So the basic steps that we're going to follow in this conjugate method is trying to introduce a radical form of this expression that is going to contain an opposite value for this, whereby we say that this particular expression for the conjugate over this numerator is going to appear in that specific form of a similar expression but with opposite units, which is multiplied on both sides of the expression, or rather this function. And then we're going to find that this radical sign is going to be solved out, and then we're going to have x plus 11 minus 16 in this specific case. And of course, we're going to see that in trying to solve this one, it's going to give us, of course, the value of x minus 5 for the numerator. And for the denominator, we're going to, of course, find out that it's going to consist of a factor that can be cancelled with x minus 5, which are similar factors. And this is going to reduce to this particular form. And then we're going to do a substitution for the value of 5 for this limit, which is going to give us an 8, given us, of course, the result of that particular evaluation. So this is one of the ways in which we can be able to obtain limits of functions, especially using this specific strategy that we refer to as the conjugate method. So that is it for now. So guys, kindly check in our description boxes for various links of other videos, and also subscribe to our channel and get us in the comment section so that we can be able to discuss more of these specific topics in mathematics, physics, chemistry, and biology. So that is it for now. Bye guys, God bless.